So let's solve question number 3. In two identical tubes A and B, tube A has both ends open while tube B has one end closed. The ratio of fundamental frequency of tube A and B is what? So before solve this question, let's understand the basic physics rule in here. At an open end, air vibrates freely, so we can get an antinode. And at a closed end, air particles cannot move, so we can always get the node at the closed end. So here, for a tube A has both ends open. For tube A, it has both ends are open. So we can draw like this. This is 1, 2, 3. This is the antinode. This is the antinode. And also middle we have node. So the both ends are open. We know the both ends are open, so we can get the antinode. Here also we have antinodes at opens. So the distance between this antinode and node is we can get half of the wavelength. And we can write this equation as lambda A is equal to 2L. And using the wave equation, we use this formula for the wave equation and we can get the FA value using the V divided by lambda A. So we know the lambda A is equal to 2L. Then we can get the finally FA value. So for tube B has one end closed. So it look like this. One end closed. So it has not here. Then we can use this formula and we can get the lambda B value as 4L. Using the wave equation as previous one, we can find the FB value by using V divided by lambda B. We know the lambda B is equal to 4L. Then we can FA divided by FB, then we can get the ratio of FA and FB. Then we can finally get the answer as C. The fourth question is the wave with the frequency above the audible range of human beings are called supersonic waves, ultrasonic waves, infrasonic waves, hypersonic waves. So to answer this question, we must look at sound frequency ranges and how human hearing works. Yes. So humans can only hear sound frequency between the 20 Hz and the 20 kHz. And any sound with this boundary is called audible sound. And ultrasonic sound waves with frequencies above 20 kHz and infrasonic sound waves with frequencies below the 20 Hz and supersonic and hypersonic faster than speed of sound. So the correct answer for this question is ultrasonic waves. Ultrasonic waves we know below the 20 kilohertz. So it can audible for the human beings. So okay, next question is decimal is a unit to measure intensity of light, sound intensity, velocity of sound, solar radiation. So the decimal is the standard unit used to measure the intensity or loudness level of sound. So the correct answer is sound intensity. So decimal is used to measure the sound intensity. So let's quickly review the correct units for the other options. Intensity of light. It measured in candela or lux. Velocity of sound. This measured this measured in meters per second, and solar radiation. This measured in watts per square meter. And next, under what two condition will a real gas behave like a ideal gas? We have answers: high temperature and high pressure, high temperature and low pressure, and low temperature and low pressure, low temperature and high pressure. So to understand this answer, let's remember what make a gas ideal. First, ideal gas molecules have no attractive forces between each other. And second, the actual size of the molecules is so tiny compared to the volume of the container that is considered negligible. And how do we make real gas molecules to ideal gas? If we apply low pressure, the gas expands to take up a huge volume. When more molecules are far apart, they don't pull on each other, so intermolecular forces become almost zero. Now, what about temperature? If we raise the gas to a high temperature, the molecules move extremely fast with high kinetic energy. So, what is the correct answer? Correct answer is high temperature and low pressure.